Welcome everybody to today's seminar. Today we will see how to use Microsoft Azure, the online service, with MATLAB. So let's start on a little recap on who we are. We are MATLAB student ambassadors, so we are the connection between Matters and Polimi students. Our aim is to help students in their use of this software, organizing events like this online seminar, and manage the community on Facebook and Instagram. Let's see the today agenda. We will start on a little introduction on Azure Educate version. We will see how to create a virtual machine with this service and how to set up this virtual machine with MATLAB. At the end, we will see a little case study in order to understand the potentiality of this setup. So let's start from the first point. Normally we have our local PC where we compute our work, where we perform our work. Our PC is connected to internet that is connected to Azure servers. The idea is to use this connection and the potentiality of the online servers to improve the performance of our computation. But why we can use Azure? The idea is that using Azure and in general online service of server computation, we can actually reduce the time consuming of high complex computation, use this server from many users. It is on demand, so we can use it only when we need actually, without wasting resources, and we can scale our operation using a powerful server or a less powerful server. But what are the normal computation, the normal operation that we can perform on this server? Normally, high computational tasks like training of neural network, simulation of a complex environment, image analysis, but also high complex mathematical calculus. What are the difference between the traditional approaches for high complex calculation and Azure, or more in general, server computation? Of course, we start from the same point, the complex computation. Normally, a company could buy a server in order to perform this complex calculus. Or, as an alternative, we can subscribe to this online service. Of course, the cost of buying a server and subscribing to Azure is completely different because Azure is more scalable. We can buy only what we are actually using. Next, we set up the server or the virtual machine. We execute the computation on both the different machine, and finally, in one case, so the server case, we switch off the server and we leave it where it is. Whereas in the case of Azure, switching off the virtual machine, we stop paying. So that's the point. With an online service, we can build our virtual machine on our need of that particular moment without wasting resources, buying a server that, of course, once we have bought it, we cannot anymore sell. So, what is inside Azure? Azure includes some different type of computational server for analysis, calculus, blockchain, container, and database. In our case, we will see how to use the server dedicated to calculus. So let's do a little recap on what we actually need in order to give some categorization of this different service. Let's make it easier. So Azure, as I said, have different sub categories like computing, storage, and other categories. We will concentrate only on computing because now we want to take our analysis on that. Computing is composed with different server with different specific tasks. So the one with CPU-oriented task, memory-oriented, and of course CPU plus GPU-oriented for graphical calculus. Our idea for today is to concentrate on CPU and GPU that are the most general type of computing cluster that we could need. In particular, there are different services inside Azure with CPU and GPU oriented, different services that of course have different performance. What I mean is that they have a different number of computational units, different GPU, and also different memory. We have selected MV6, that is the most powerful that we can select with our student account. So let's recap. Azure is the service, okay, is the global service of Microsoft. MV are the family of Azure instance of the type that we have selected. MV6 is the machine that we actually have selected. So 6 virtual CPU, 56 GB of RAM, NVIDIA M60 GPU. In particular, this one costs 0.92 euro per hour of use. In our case, we have $100 of credit for free because we are students. So now let's see how to create actually a virtual machine, because that's the focal point. In order to create the virtual machine, you should go to this website, azure.microsoft student service, and activate your student account that to obtain 100 of USD in credit. Once you have done this procedure, you are ready to start creating your virtual machine. So let's try together to see this procedure with a demo. Okay, I'm already in the Azure website. As you can see here, I'm already logged in. Once you have activated your student account, you can see the same screen. You can simply click on Portal, and you can access your Azure Service Portal. As you can see here, there are lots of different type of function. What we are interested in is virtual machine, this one. So we start virtual machine. As you can see, I have no virtual machine created. In this list, normally you will see all of your virtual machine ready to start up. What we can do is to add a new virtual machine. So I click on add. So let's create our virtual machine. We have to select some option in order to fit our virtual machine for our purpose. So we have to select the group. So I created MATLAB group, the name, like MATLAB PolyMe, the region is okay. Now we have to select the image of the operating system. Let's select, for example, Windows 10 Pro, because it's easier to use MATLAB on this operating system. Now we have to select the size. Size, what it means is the type of virtual machine. So as you can see here, I have different size that I can select. Let's try with, for example, MV6 Pro. I can select it. So I've selected my MV6 with 6 virtual CPU. Now I have to enter a username that I can decide. For example, Daniele, and a password. Okay, so I have inserted my password. Now I select the port to access, and clicking on review and create, I'm creating the virtual machine. Now let's return to our slides. Let's recap our procedure to create the virtual machine. We have opened Azure portal. We have selected the virtual machine service. We have created a new resource group, and selecting Windows 10 Pro and the dimension of the virtual machine, we have created and instantiated our virtual machine. Now we have now a blank virtual machine, so there is a the virtual machine with Windows 10 Pro installed, but not MATLAB. So what we will do now, in particular my colleague Alberto, we will show you that how to connect remotely to the virtual machine, how to install the GPU driver and MATLAB in order to use it. So I'll hand the word to my colleague Alberto. Thank you.
Thanks, Daniele. And now let's start from the checkpoint. First of all, as just shown by my colleague, we have built our blank VM. Now what we have to do is to connect remotely, install GPU driver. That is very important because now the machine is completely blank without any software, and then install our core that is MATLAB. Okay, how to do this? First of all, we have to connect remotely to the virtual machine. So let's switch on the browser. We are now on the browser. As you can see, we are in my virtual machine portal, and we have our MATLAB test virtual machine. Now we can go here on the right corner and click the three dots and select connect. Once you have selected connect, you will see this particular windows on which you can find your IP address and the number of the port. Now, by clicking RDP, download RDP file, you can select, you can download the connection file, click OK, and proceed with the connection. Now, I have already opened the machine, and what you can do is to open the continue the procedure, and you should end up with this visualization. So you have a complete fresh Windows 10 machine. Now, first of all, as I just said, you have to download the driver for NVIDIA, in particular for the NVIDIA on this machine. So you simply do a research on Google and you search for Azure NVIDIA driver. Then, by selecting the link and following the instruction, you can download the driver. How you can understand if the driver is correctly installed? You can go on the device manager, and you can find, or you should find, NVIDIA Tesla M60 as your core graphic cards. Okay. Now, for the setup of the machine, we are in a good let's say position. We have created our machine. We can connect remotely, and what we can do is, of course, if you have other system different from Windows, you can use different apps like Remote Desktop for Mac or Remina if you are using Linux. I just said you have to select and download the driver specific for grid graphics card that is a little bit different from the usual one. And now we are ready to set up MATLAB. In order to set up MATLAB, what you have to do is to go on the MathWorks site, so mathworks.com, log in with your credential, and download the latest release of MATLAB. I will not show step by step because it's the usual way to download MATLAB and install it. I strongly suggest you to download also all the packages because you don't have any problem of space, and so you can have all the packages without any trouble later. Okay, so we have now finished. We have our computer with Remote Desktop, and we can connect to our cloud service that is Azure with MATLAB installed on it. And this is very easy. So at the beginning should sound something very complex, but as you can see now, I completely show you how to step by step end up with your virtual machine functioning. Okay, so now I want to show you one case study that, in my opinion, it can be very interesting and challenging because it's one of the most computationally intensive tasks. In particular, this is a neural network problem. So we would like to create a simple deep learning classification network that can identify the number root and then give you as output the real number as integer. Okay, so we want to create a convolutional network. we will learn to load data, to define the network architecture, and so on. So what we will do is take some sample, okay, lots of images of this number, train the convolutional neural network in order to have a functioning network that once you give in a picture of a number, respond, so give out the number. As with these slides show you, so a image that also is not very sharp will be processed and then give the information. So with this link you can open the script and follow me with the digging into the code. Okay, so let's move in the code. Remote test. Here we are. Okay, you can open MATLAB and you can select. You can write the here in the command windows the correct string. Once you open the file, you should see. First of all, load and explore image data. What this part does is to load into the workspace all the information needed to train the network. In particular, the datasheet, the information about the images, and other classification, so the folder in which you have the pictures. So we run it. Okay. Remember that all the things I'm showing you is not on my PC, but are done in remote. So also, as you can see, the flow of the mouse and the user interface, the experience is very good. I'm not feeling any lag or issues. Okay. Then moving on, we can display some picture of the images that I just load in the workspace. In particular, as we can see, we can pick some random images between the ones we have loaded. And here we can see there's a 0, a 2, 5, 9, and so on and so forth. Now we have to calculate the number of images for each categories, because of course we to train the network we have to say to the computer that the first image here is a 0, the second one is a 2, so he can classify and build a consistent data set. We can execute it and it should say that, let's give some time. Okay, perfect. For each number we have 1000 images. Perfect. This is a very consistent, a very, let's say, extensive data set. Now, moving on, we can look at the image size. That is very important because our neural network can fit only a specific type of images, and in particular is 28 for 28 image for one layer of color, so black and white. Okay, now we have to do some very specific steps. Some steps that are strictly related with the neural network. Okay. First of all, we have to decide how many of these images will be the training file and how many will be the validation dataset. Then, once we have performed this part, we can define the structure of our neural network. I'm not going to detail it all this layer, but the important thing is that as the name neural network suggests, in particular deep learning that is a part of neural network in general, it suggests that is something deep. So you have lots of layers, and each of these layers will do some operation. Of course, here we have a detailed information about what does each layer, and if you're interested, I strongly suggest you to go and read this information. Also, there's lots of training courses online to do this, also in MATLAB. Okay, we perform this operation and it creates some file here, layers, that is the structure of our neural network. Now we have to specify some training option. So like the speeds of converging to the solution and so on, and this is usually something that if you are not a very expert on this field, you can take it as it is. We can run this part, and now we are to the core of this let's say procedure, the time of the training of the neural network. Now, before I run this part, I already prepared here the task manager that in Windows show us the resources that the machine is using. In particular, you can see here we have the CPU, the memory, disk, Ethernet, and the GPU, that is the core of this training. Now it's comfortably sitting at 9%. Now we are ready. We can move on MATLAB. We can hit run. Now will pop up the windows of the training. Let's give him a second. Okay, he detects the GPU. He says that the capability is 5.2, that is okay. And also the GPU now have a little spike. Here we are, initialization. Good. Okay, leave it here. Maybe a little bit smaller. Okay, not very good. Okay, perfect. As you can see now, the use of the memory, the GPU is going up, and also the CPU. Now, as you can see, it's very fast. We just perform a 30-second training, and we perform 2032 iteration. That is a significant number, and we just increase the use of the GPU by a little, and the CPU by some considerable part. This means that we have a very strong and powerful machine, and that is designed and built to do this type of computation. Now we have performed the training. Okay, we can close this part. Okay, now the live script show us the image, and now we are ready for the last part, in which we can validate the neural network and the prediction. In particular, we can see here we have an overall accuracy of 0.98, so 98%. That is quite good. Okay, for the example of today, for this case study, I end. Let's move on the presentation. Okay. Demo time. I just show you. Okay. We are at the end of this little seminar. I thank you very much for this the time you give us and you spend to look at this seminar. Of course, this is our emails. Now, if you want, there's a round table on WebEx. At the link you can find in the first comment, or you can and I suggest you to add to our social network, Facebook and Instagram, and also to be updated with our new videos and follow this interest. I hope interest example and webinar. I strongly suggest you to put a thumb up in the video and subscribe to our channel. Okay, for this, for me it's all. Thank you and see you next time.